Alright, you guys, Unit 2, Functions and their Graphs. I am going to mention this in class. One change I would like to make in this unit that we didn't do last unit. Anytime you guys see a U-try, I would like you guys to try that problem while you're doing your notes. So whenever you get to a U-try, pause the video and then see if you can do the problem. The next day in class, I will go over any questions you have on the U-try problems, but I will not go over them the way I have been. I did that in the first unit because everyone was still getting used to the videos, and a lot of people dropped out and then came back, and it just seemed like a good idea. But really, if you can do the U-try problems, that means you understood the example. This is how I determine whether or not you understood the example. If you don't understand the example and you have trouble with the U-try, I can help you with that in class tomorrow, but I really want you to try this while it's fresh in your mind. So immediately after the example, just pause the video, try this one out, and then go from there. Alright, this one doesn't have a U-try though. Example 1, the figure below shows a relation between states and the number of representatives each state has in the House of Representatives. The relation might be named number of representatives. Okay, so basically they just want to know if you can tell what number each state corresponds with. So, for example, Alaska corresponds with 1, Arizona corresponds with 8, North Dakota corresponds with 1, etc. There we go. So I basically just listed all of these states with their corresponding number. Okay? Okay, example 2. Determine which of the following relations represents a function. If the relation is a function, then state its domain and range. Okay, so I hope that you guys kind of remember the difference, how to determine whether or not a relation is a function. If you don't, we'll go over it here. For this relation, the domain represents the level of education and the range represents the unemployment rate. Okay, so every input variable, these would be the input variables, and corresponds with a unique output variable. These would be the output variables. So yeah, it's a function. Okay, they want the domain and range. Here we go. The domain would just be the list of the input, and the range would just be the output. So I just listed them out. For this relation, the domain represents the number of calories in a sandwich from a fast food restaurant, and the range represents the fat content. Okay, so we have calories here, we have fat here, and each element in the domain corresponds with exactly one element in the range. Okay, so it is in fact a function. I'll go ahead and write the domain and range here. It's kind of split. Hopefully I can fit it. I just wrote down the number of calories for each of the elements in the domain just to make it a little bit shorter. You're welcome to do that if you come across a similar situation. Alright. For this relation, the domain represents the weight in carats of pear-cut diamonds and the range represents the price in dollars. Okay, so we have carats here, we have price here. This does not represent a function because each element in the domain does not correspond with exactly one element in the range. So if you can see 0.71 carat diamonds, it corresponds with this price and with this price. Okay, that means that you cannot have two output variables for the same input variable. Otherwise, it's not a function. Okay. Hopefully you guys find this particular U-try kind of easy. Let's go on to example 3. Alright. Example 3. Determine whether each relation represents a function. If it is a function, state the domain and range. Alright. When we're given a list of ordered pairs, it's kind of easy because all you have to make sure is that it does not have any of the same x variables. If none of the x variables are the same, it is a function. So in this case, the domain is 1, 2, 3, 4. Okay, and the range 4, 5, 6, 7. For part B, once again, none of the x's are the same. So we've got 1, 2, 3, 6 for the domain, and the range is 4, 5, and 10. You don't have to write the 4 twice. Now for this one, we have two -3's. That means there's an x variable that corresponds with two different y variables, an input variable that corresponds with two different output variables. That's not going to work, so this is not a function. Alright, you guys go ahead and try this one. Let's take a look at example 4. Determine if the equation y equals 2x minus 5 defines y as a function of x. Basically, they're asking, is this a function? A couple different ways you could do it. I actually favor graphing it. If you were to graph this, hopefully you guys can see your m and your b. Your m is 2, your b is -5. So you're going to start at -5, go up 2 over 1. Now hopefully you guys are familiar with the vertical line test. We're actually going to be learning that in the next unit, but I'm hoping that's review. If you were to draw any vertical line through this graph, it is only ever going to hit the graph once. That means for every x variable, there is exactly one y variable. You're never going to have two y variables for the same x variable. So this is a function. You could also plug in things for y and see what you get for x, and eventually if you plugged in enough numbers, you would see that for each number you plug in for y, you're going to get something different for x, which indicates that it is a function. Alright, example 5. Determine if the equation, let's see, let me change back to blue, x squared plus y squared equals 1 defines y as a function of x. Alright, hopefully you guys remember that this is an equation of a circle. From the last unit, hopefully you remember. It centers the origin, and the radius is 1. So I'll just make that the circle. If you were to do the vertical line test here, you're going to hit the graph in multiple places. So this is not a function. Okay? You guys go ahead and try this one. You're welcome to use your calculator if you're not sure what the graph looks like, okay? Okay, this one is just a reading example. Consider the function f of p equals p squared. The name of the function is f. The independent variable or argument of f is q. If q equals f of p, then q is the dependent variable. Since f of 3 is 9, that's if you plug in 3 for p, you're going to get 9 because 3 squared is 9. We say that 9 is the value of f at 3, or 9 is the image of 3. Okay, so a couple keywords here that might pop up again. Because we can square any real number, the domain of the function is the set of all real numbers. That means that I could plug in any number I want into here. Any number would work. Could be negative, could be positive, could be big, could be small, could be a fraction, anything. Because I can plug in any number, my domain is from -infinity to infinity. Using interval notation. Because the square of any real number is greater than or equal to 0, the range of f is 0 to infinity. Okay, whatever you plug in for p, you're always going to get a positive number. If I plug in 0, I'm going to get 0. If I plug in 5, I'm going to get 25. If I plug in -5, I'm still going to get positive 25. There's nothing I can plug in here that will give me a negative number. So my range is only going to be from 0 to infinity. Okay. All right. Example 7. For the function f defined by this. Actually, you know what? I think I'm going to end the video here and save that for the next video. Okay.